Hello class, in this video we will look at the effects of temperature on an equilibrium system. Unlike the other factors that we've covered, temperature is the only factor that will affect and change the value of the equilibrium constant. However, we need to be mindful of the nature of the forwards reaction to predict whether the value of Kc will increase or decrease. This means that we need to know whether the forwards reaction is exothermic or endothermic, and this is reinforced by the table below. Although this table provides a good summary and may be worthwhile memorizing, it is important that you understand why these changes are taking place. Because we are disrupting the system by heating it or cooling it down, we could use Le Chatelier's principle to predict which direction equilibrium will shift. We will start with the exothermic reactions first. Exothermic reactions are characterized by releasing heat to the surrounding environment. If we were to increase the temperature by heating up the system, we know that the system will partially oppose the increase in temperature, and it does this by favoring the reverse reaction. The reason why it favors a reverse reaction is because the reverse reaction, or the dissociation of ammonia into nitrogen and hydrogen gas, is an endothermic process which allows the system to absorb some of the heat that was added. Since equilibrium lies to the left, we should expect the concentration of the reactants to increase over time and the concentration of the products to decrease over time. Let's show these changes on the concentration time graph. As we said earlier, by heating the system, it favors the endothermic reaction, which occurs in the reverse direction. Hence, the concentration of nitrogen and hydrogen gas should increase. Please be aware that the coefficients of nitrogen to hydrogen is 1 to 3. Hence, the change in concentration for hydrogen gas should be 3 times the size of nitrogen. On the other hand, ammonia gets used up and the concentration decreases, and it should decrease by 2 times the amount nitrogen went up by. Let's now consider how increasing temperature affects the value of the equilibrium constant. We know that the equilibrium constant is a ratio of the concentration of the products over the concentration of reactants. Since the concentration of the products has decreased while the concentration of the reactants has increased, the value of Kc will decrease and become smaller. Let's now examine the effects of decreasing temperature on an exothermic system. If we allow the system to cool down, let's say in an ice bath, temperature would decrease. The system will partially oppose the reduction in temperature by favoring the exothermic reaction which takes place in the forwards direction. Because this shifts equilibrium to the right, the concentrations of nitrogen and hydrogen decreases, keeping in mind that hydrogen should decrease 3 times more than nitrogen given the stoichiometric coefficients. Meanwhile, the concentration of ammonia increases over time. Overall, the concentrations of the reactants have decreased while the concentration of the products have increased, thus making the value of the equilibrium constant more larger. In the second part of this video, we'll now explore the effects of temperature on an endothermic reaction mixture. By introducing heat into the system will try to dissipate the heat by favoring the endothermic reaction to absorb some of that extra heat which occurs in the forwards direction. Because equilibrium shifts to the right, the concentration of NO2 increases whereas the concentration of N2O4 decreases. Given the following changes, it would make sense that the value of the equilibrium constant will increase because the value of the numerator increased while the value of the denominator has decreased. If we cool down an endothermic reaction instead, the system will partially counteract by favoring the reverse exothermic reaction in an attempt to release some of that heat. Since equilibrium shifts to the left, the concentration of N2O4 increases while the concentration of NO2 decreases. This will in turn decrease the value of Kc because equilibrium lies to the left. Time to see if we can now apply our understanding. Make sure you pause the video at the beginning of each question to give yourself some time to formulate your answer. For question A, the first part of the question reads, what is the effect of the position of equilibrium when the temperature in reaction A is increased? Explain your answer. Given that the enthalpy change is positive, we know that the forwards reaction is endothermic. If we increase the temperature, the system will favor the endothermic reaction or the forwards reaction in an attempt to partially absorb the excess heat, therefore equilibrium shifts to the right. The second part of this question asks, what is the effect on the position of equilibrium when the temperature in reaction B has increased? Similarly, the system will partially oppose the increased temperature by favoring the endothermic reaction. However, the endothermic reaction occurs in the reverse direction, hence equilibrium shifts to the left. In the second question, we need to sketch the changes if the temperature of the equilibrium mixture was increased. According to the thermochemical equation, this reaction is exothermic in the forwards direction. By increasing temperature, the equilibrium mixture will oppose by favoring the endothermic reaction, which occurs in the reverse direction. Because equilibrium shifts to the left, the concentration of the ferric ion and thiocyanate ion increases, whereas the concentration of iron 3 thiocyanate ion decreases as illustrated on the graph. In this question, the system has been heated and the question wants us to identify the correct equation and whether the forwards reaction is exothermic or endothermic. By analyzing the concentration time graph, notice how both Q and R has decreased. This suggests that it should be on the same side of the equation, hence we can eliminate options B and D. Both options A and C are exothermic, but the difference is the placement of the gases in the equation. If the equation is exothermic, it will favor the reverse endothermic reaction. Given that Q and R both decrease in concentration, the correct answer should therefore be A. In the fourth question, we want to choose the set of conditions that shifts equilibrium to the right to get the most conversion of reactants to products. In this reaction, there are more molecules on the products, hence we should increase the volume because the system will partially oppose the reduction in collisions by favoring the reaction that produces the most molecules. As a result, we can eliminate options C and D. Given that the reaction is endothermic in the forwards reaction, we can shift equilibrium to the right by increasing the temperature as the system will partially oppose by favoring the forwards endothermic reaction, hence A is the correct answer. In the second last question, we need to identify the correct changes that took place at the 1 minute and 7 minute mark. Given the shape of the concentration time graph, we know that temperature was altered at the 1 minute mark because temperature does not result in a sharp increase or decrease in concentration. We can see that the concentration of both chlorine gas and carbon monoxide increased, suggesting that equilibrium was shifting to the left, favoring the endothermic reaction. Because it's favoring the reverse reaction, the system was originally heated, hence we can eliminate options B and C. Furthermore, the concentration of all gases in the mixture decreased at the 7 minute mark as illustrated by the sudden drop. This suggests that the volume was increased since concentration and volume was inversely proportional. Hence A is the correct answer. And for the final question, we know that the reaction is exothermic in the forwards direction. The question wants us to identify the change that has occurred at T1 and the color change at T2. Because the graph shows the rate of the forwards reaction has increased, which favors the exothermic reaction, this means that the system was cooled down or the temperature was decreased because the system favored the heat releasing reaction. Therefore, we can eliminate options A and B. Given that the forwards reaction is favored, this means that N2O4 is produced as the system reaches equilibrium. Because N2O4 is a colorless substance, the color of the reaction mixture will progressively become lighter, hence C is the correct answer. This is the end of the video. I hope this video was informative. Thank you for watching and I'll see you guys again in the next one. Bye.